part. First part we are going to cover the rotary part. We are going to cover the reciprocating part. We combine them, that is rotary plus reciprocating, because every machine has both rotary plus reciprocating. So as far as rotary is considered, first of all the question is that why we require balancing. That is the question to be answered. Now because of the balancing is a problem. Okay, let's consider one disc, and this disc is made up of certain material. Now either the disc is produced by using casting or by some any other methods. Now you know though, casting is, when we are pouring the casting, sometimes the density of the material will not be uniform over the structure. That is a casting defect, may be possible. So let's say we have a constant mass at a certain point. We have uniform mass, but some extra mass is collected at this point. Either we can say it's a casting defect, or we can say we have a concentrated mass at that point. It is always present here. Now because of this concentrated mass M, which was situated at a distance equals to, from the axis at distance equals to r, that is radius r, or we will call this as eccentricity. And as this rotor will rotate, then because of this rotation omega, will this mass which I have shown here is this only point mass, rest mass is balanced. We have no objection with the rest mass. Which was creating a problem is this mass. Now if you put so I am showing this extra mass which is creating a problem for me, and is at a distance equals to what? R. Now as soon as we start rotating this with a speed equal to omega, will this experience a centrifugal force? Now if it experiences a centrifugal force, Fc is equals to m into omega square r. So this centrifugal force is depend on radius r, at which we have a eccentric mass, and the speed of the shaft. Now these two supports will give you two reactions. So one reaction will be here and one reaction will be here. Now remember here, these reactions are not going to be constant. They are variable reactions. Why variable reactions? Because this mass is rotating in this plane. So as the mass will rotate, the reaction will also rotate. If you try to draw the FBD of this one, so if you try to draw the FBD, you will get FBD will be like this. This one is AY, this one is, let's say this one is BY, so this one is AY and this one is BY, and either centrifugal force will acting downward. Now if the centrifugal force will act downward, is the magnitude of centrifugal force, I will just write Fc now, is equals to what? M into omega square multiplied by radius r. And if I say it is exactly placed at center, I will say this distance equals to A as well as this distance equals to A. Or it is unsymmetrical, then I will say this distance is A, this distance is B, then the total distance is equals to L. And about point A, so this moment is what? Clockwise. So sum of moment of all forces about A, clockwise is positive, must equal to what? 0. So this Fc multiplied by A, is it a clockwise moment? And By multiplied by L, is it anti-clockwise moment? So this one is By multiplied by L equals to 0. So are you getting a reaction equals to By is equals to Fc multiplied by A divided by what? L. And again we can apply the second equation is sigma Fy vertically upward positive must equal to 0. In that case Ay plus By minus of Fc must equal to 0. So if I put this value back, I am able to calculate the value of Ay, which is my Fc minus By. So this is Fc minus Fc multiplied by A divided by L. So I can multiply this L here. So L is common, and when I multiply, I will, instead of Fc, I will write A plus B. Is A plus B is okay? L is multiplied and L is equal to what? A plus B minus of Fc multiplied by A. So if you open the bracket, is FCA and FCA get cancelled, and are you getting the reaction equals to what? AY multiplied by FC multiplied by B divided by L. Now depending upon the value of A and B, either AY is more or either BY is more. And if it is centrally placed, then both reactions are same. But if you consider the SFD of this figure, SFD, shear force diagram, then is this force will go upward, and if this force will go upward, then from here to here is your force is constant, then it force downward, and from this point to this point is the constant again, and we have a closing value. So this one is your SFD. This distance is A, this distance is B, this distance is what? AY, and this distance equals to what? BY. Now this area, is it above the reference line? So this one is positive quantity and this one is negative quantity. If we have the shear force, naturally we have bending moment also. And the bending moment is this is the rectangle, and the bending moment is always a triangle. Degree decreases and then is again so this one is positive value, so it will rise and then it will fall. So can we able to find out what is the maximum height? So maximum height will be equals to what? AY multiplied by A. If you put this value back into AY, you will get FC into B into L. FC into A into B divided by L. And you get the same value from this side also. So do not bother about this one. Now because of bending moment, that is M, if this shaft is subjected to bending stress, that equal to what? M by I sigma B by Y. Is that correct? So because of bending stress, is this shaft to fail at this point? That is one reason. Second reason is that